Good morning, students. In this session, we will continue with the topic ionic bond. Ionic bond. Now, you might have learned the basic definition in high school as the bond formed by transfer of electrons. Even in CBSE and ICSE students also might have studied. Okay, bond formed by transfer of electrons. Bond formed by transfer of electrons. Bond formed by transfer of electrons. Electrons means where to where. That point should be specified. This definition is enough for schooling. But where? Electron is transferred from where? Which atom to which atom? What type of atom to what type of atom? All these points must be specified. Then only this definition is said to be a complete definition. So let us start with an example. Then we will form the definition. We will frame the definition from that example. Consider sodium atom. Example, we take sodium chloride. Sodium chloride, an ionic compound. Here it is formed between sodium atom and chlorine atom, right? Sodium gaseous atom electronic configuration is 1s2, 2s2, 2p6, 3s1. So this is the first shell, this is second shell, and this is the third shell, which is the valency shell for sodium. Now, as it has only one electron in the outer shell, it needs 7 more electrons to get octet, which is quite not possible. That's why sodium readily loses one electron and become Na plus gaseous ion. Na plus gaseous ion. So, after losing one electron, Na become Na plus and its configuration is 2s2, 2p6. This is 3s0. Now, this is third shell is no more the outer shell for sodium ion. See, now 2s2, 2p6. is the outer electronic configuration for Na plus ion, which is a stable octet set of configuration. This is also equal to neon electronic configuration. That's why to attain this nearest inert gas neon electronic configuration, sodium readily lose one electron and become Na plus ion. When it comes to chlorine atom, whose atomic number is 17, this is 11. Chlorine atomic number is 17, and electronic configuration of chlorine can be given as 1s2, 2s2, 2p6, 3s2, 3p5. 1s2, 2s2, 2p6, 3s2, 3p5. First shell, second shell, and third shell, which is the outer shell here. In the outer shell, chlorine has how many electrons? 7 electrons. According to octet rule, an atom will be stable if it has 8 electrons. Chlorine has 7 electrons, so it needs one more electron to get octet. By gaining one electron, it becomes 3s2, 3p6 configuration, which is the configuration of nearest inert gas, that is argon. So that's why whatever the electron lost by sodium, that can be readily gained by chlorine. When an atom gains one electron, it becomes an anion. We are aware of this. When an atom loses one electron, it becomes its cation. So chlorine gains that electron and becomes Cl minus gas. This is also gas, of course, whose electronic configuration is 1s2, 2s2, 2p6 and 3s2, 3p6. This configuration is similar to argon configuration. Thus, sodium gets stabilized as Na plus ion with neon electronic configuration. Chlorine gets stabilized as Cl minus ion with argon configuration. Configuration wise, they are stable, but species wise, they are not stable because they are charged species. Neutral species is relatively more stable than the charged species. We are aware of that. Now what happens, as these two are oppositely charged species, as these two are oppositely charged ions, they will be attracted to one another. You know that electrostatic force is the force of attraction between two oppositely charged ions. So because of that electrostatic force of attraction between two oppositely charged ions, Na plus and Cl minus will be held together, and thus an ionic bond is formed. So what happens? Na plus and Cl minus gaseous ions will be held together to give NaCl. Of course, that will be crystallized in solid form. This strong electrostatic force of attraction between these two oppositely charged ions is called as ionic bond. So what's the modification of the definition? Strong, let us write the full form. Strong electrostatic force of attraction. Strong electrostatic force of attraction. Which are having this attraction? Which order the species held? Between two oppositely charged ions. Between two oppositely charged ions. What are those ions? Na plus and Cl minus, for example. Now my question is, how these two ions are formed? How these two ions are formed? Formed by transfer of electrons. See, transfer of electron or electrons. It may be one electron or several. Strong electrostatic force of attraction between two oppositely charged ions formed by transfer of electrons from where to where the electron is transferred? From the outermost orbit of sodium, the atom with low ionization potential, to the outermost orbit of chlorine, the atom with high electron affinity or electronegativity. From the outermost orbit of this sodium of low ionization potential to the outermost orbit of chlorine of high electron gain enthalpy, means electron affinity. Its electron affinity is very high. Chlorine's electron affinity is very high. It readily gains electrons because just by gaining one electron, chlorine will get octet set of configuration. That's why it has very high affinity towards gaining electrons. So that point also must be specified. Otherwise, it won't be a complete definition. So once again, strong electrostatic force of attraction between two oppositely charged ions formed by transfer of electron or electrons from the outermost orbit of an atom of low ionization enthalpy. From the outermost orbit of an atom of low ionization enthalpy to the outermost orbit of an atom of high electronegativity or electron affinity. To the outermost orbit of an atom of high electronegativity or electron affinity. So this gives a complete definition of ionic bond. Otherwise, see, if students learned this definition in class 10th, bond formed by transfer of electrons, that definition is not enough. When this much concept is involved in defining ionic bond, how can we be satisfied with this small definition? Okay, so what's the complete definition? The strong electrostatic force of attraction between two oppositely charged ions. How these ions are formed? Formed by the transfer of electrons from the outermost orbit of an atom of low ionization enthalpy to the outermost orbit of an atom of high electronegativity or electron affinity is said to be ionic bond. Is said to be ionic bond. So this is a complete definition. Now we can frame several extra points about ionic bond. Ionic bond is possible between. Now we can frame possible between atoms of high ionization potential or ionization enthalpy and high electron affinity or electronegativity. What are atoms with atoms of high ionization potential or low ionization potential? Low ionization potential, right? See, we have to recap such points. Atom of low ionization potential and high electron affinity or electronegativity, right? What are atoms of low ionization potential called as? Atoms of low ionization potential are said to be more electropositive. Ionization potential is a measure of electropositivity. Ionization potential is a measure of electropositivity. So less the ionization potential, more is the electropositivity. Electropositive elements are called as metals. Okay, and elements with high electronegativity are usually called as non-metals. So this ionic bond is possible between metals and non-metals. Ionic bond is usually possible between metals and non-metals, right? Thus, what are the possible combinations for these ionic bonds? Just now we discussed, no? Ionic bond is possible between metals and non-metals, where metals are usually 1A and 2A group elements are metals, and strong non-metals are in 17th group and 16th group. Even 15th also, nitrogen and phosphorus are non-metallic in character. So between 1A group element and 7A group element, 6A group element and 5A group element. Okay, you should remember other group numbers also, 17th group, 16th group and 15th group, right? So what are the ionic compounds that are possible between? Okay, let us take 17th and 16th groups. Similarly, between 2A group element and combination of ionic bond is 7A group, that is 17th group, and 6A group, that is 16th group. So what are the combinations? 1A group element you take, for example, sodium. Sodium, 17th group element you take chlorine, NaCl, we already discussed. Right? Similarly, take other 1A group elements. What are 1A group elements? Lithium, sodium, potassium, rubidium, cesium, francium. Now you take potassium. From 1A group, potassium. From 17th group you take fluorine, potassium fluoride. And suppose you take rubidium chloride, cesium fluoride, etc. These are all examples for ionic compounds possible between alkali metals, means metals and non-metals. Element with low ionization potential and element with high electronegativity and electron affinity. The same way, what are the ionic compounds possible between 1A group element and 6A group elements? Take the same metals, sodium, potassium, rubidium, cesium. Sodium and oxygen family members are oxygen, sulfur, selenium, tellurium. You can take any combination. Na valency is 1, oxygen valency is 2. We discussed it just now. For this purpose only I explained that. So crisscross method, Na2O1. So this is one ionic compound. Suppose you take potassium, another element from this, sulfur from 16th group. Sulfur valency is 2, potassium valency is 1. Crisscross. So K2S. Like this, we can frame some ionic compounds with respect to their valencies. So these ionic compounds are possible between strong metals and strong non-metals. So use that logic. Similarly, let us frame some more ionic compounds between alkaline earth metals and corresponding non-metals. All alkaline earth metals, what are they? Beryllium, magnesium, calcium, strontium, barium. Right? Radium is radioactive. I understood your doubt. Sir, you pronounced beryllium, but you didn't copy that here. Beryllium compounds are not ionic, even though it's a metal. Beryllium compounds are covalent rather than ionic because of polarizing power of Be2 plus cation. That's the point to be remembered. Similarly, from alkali metals also, lithium, sodium, potassium, rubidium, cesium. Francium is a radioactive element whose chemical properties were not studied much. So here also lithium compounds are covalent, not ionic. That's why here I didn't consider lithium. Here I didn't consider beryllium. Why? What's the reason? Tell me. Compounds of lithium and beryllium are more covalent than ionic due to the polarizing power of their smaller cations. Now frame some compounds. What are 17th group element? Fluorine, chlorine, bromine, iodine. Here oxygen, sulfur, for example. So magnesium and fluorine, MgF2 is another example for ionic compound. MgCl2. Suppose CaCl2. Okay. SrCl2. BaF2. Like this. We can frame different ionic compounds. And when it comes to another combination, alkaline earth metal and 16th group element, magnesium and oxygen. Magnesium valency is 2. Oxygen valency is also 2. Crisscross, Mg2O2. Simple ratio is Mg1O1. Similarly, CaS, calcium sulfide. SRO, strontium oxide. Barium oxide. See, these many ways we can frame ionic compounds. Even we can have other combinations also. Suppose 3A group elements. 3A group elements also can form ionic compounds with 7A, 6A, etc. Even with 5A group elements also possible, but their covalent nature is more pronounced. The reason we are going to study in Fazan's rules and others coming topics. Suppose 17th group elements are fluorine, chlorine, bromine, iodine. This is oxygen and sulfur more pronounced. This is nitrogen and phosphorus. Suppose 3A group element means boron, aluminum. Boron compounds are more covalent in character. Aluminum, best example is aluminum. AlF3 is more ionic among these different combinations. Similarly, Al2O3 is also slightly covalent character is more pronounced, but still it shows ionic character because of a smaller Al plus 3 cation. Similarly, aluminum nitride, but as we move to other combinations, their covalent character is more pronounced than ionic character. Okay. Now, let's discuss the factors influencing the formation of ionic bond. Factors influencing formation of ionic bond. Factors that influence the formation of ionic bond. Ionic bond is possible between cation and anion, right? So, for discussing the factors influencing ionic bond formation, we have to discuss in detail about the factors that influence the formation of cation as well as anion. So, it is of two categories. One is factors influencing the formation of cation. What's the full form? Factors influencing formation of cation, and other one is factors influencing formation of anion, right? Now let us discuss one by one. Cation means what's the meaning? Cation means which has a positive charge. How to generate a cation from an atom? By removing an electron. Removing electron means it won't allow usually. What sort of atoms? From what type of atoms we can remove electron? Tell me. See, I will give you two atoms. One is larger atom, other one is smaller atom. Among these two atoms, from which one you can remove an electron quickly, easily? Among a larger atom and a smaller atom, from which one electron can be removed easily? Where electron is weakly held to the nucleus. The electron that was weakly held to the nucleus can be easily removed. Weakly held means when it is weakly held, if it is far from the nucleus or closer to the nucleus. If it is closer to the nucleus will hold the electron strongly, firmly. When the distance is more, nucleus cannot hold the electron, and such an electron can be easily removed. So, what type of atoms can form a cation readily? With the atoms with a large atomic size. So, first factor is atomic size or large atomic size. Atomic size or atomic radius, whatever it is. So, larger the size, easier is the formation of cation. Larger the size, easier is the formation of cation. Suppose, if you are asked about Na plus and Rb plus, which cation can be readily formed? Sir, how to answer? Which cation can be readily formed means, first of all, you compare their atomic size. Lithium, sodium, potassium, rubidium, cesium. This is how the atomic size is varying, yes or no? So, larger one can readily lose electron. Larger the size, more is the ease of formation of cation. So, Rb plus, ease of formation of Rb plus is greater than Na plus. This is how the first factor can be discussed. Next factor is low ionization potential or ionization energy, whatever it is. Time being, we can discuss ionization energy and ionization potential as same. There is a slight difference conceptually, but time being we can use that. Low ionization potential means, what's meant by ionization potential? Energy required to remove a loosely held electron from the outermost orbit of an isolated gaseous atom, right? So, consider two atoms. Atom 1 with the low ionization potential means less energy is sufficient to remove this electron. Another atom with high ionization potential. Now from this discussion we can say, when less energy is sufficient here to remove this electron, it can form a cation easily than the one having high ionization potential. So, less the ionization potential, easier is the formation of cation. In that way, another factor is less ionization potential. Atom with less ionization potential can readily form a cation. Atoms with low ionization potential can readily form a cation. Third point is less charge on ion. Third point and important point is less charge on ion. Suppose you are given with the Na plus and also Mg2 plus. Na plus is given and Mg2 plus is given. Which among them is readily possible, readily formed? To form Na plus, only one electron is to be removed from sodium atom, whereas to remove Mg2 plus, 2 electrons are to be removed. Energy required for the removal of first electron is called as first ionization potential, whereas for magnesium, energy required for the first electron removal is first ionization potential, next electron is second ionization potential. So here more energy is required, for the removal of, for the 2 electrons and for the formation of Mg2 plus. So among these two, which ion can be easily formed? The one with less charge. Less the charge, easier is the formation. Okay, I think you followed this one. Less the charge, easier is the formation of such cation. So less charge on the ion, easier is the formation. That is the next factor. And the next factor is stable electronic configuration. Stable electronic configuration means ion with stable in the sense, what are the electronic configurations we have studied so far? Tell me. One is half-filled electronic configuration, other one is a completely filled electronic configuration. Both give stability to the atom we studied, right? Other than this, we have one more electronic configuration, that is pseudo inert gas configuration. See, I am repeating. Stable electronic configuration in the sense, two ways are there. One is inert gas configuration. One is inert gas configuration and other one is pseudo inert gas configuration. Pseudo inert gas configuration. There are two types of stable electronic configuration other than exchange energy concept. In exchange energy concept, we discussed half filled or completely filled orbitals give stability. Other than that, there are two types of stable configuration. Inert gas configuration means NS2-NP6 octet set of configuration. Pseudo inert gas configuration means NS2, NP6 and ND10. Means having 8 electrons is said to be inert gas configuration. Having 18 electrons is said to be pseudo inert gas configuration. False inert gas configuration it is called as. 8 electron configuration is inert gas. 18 electron configuration is pseudo inert gas configuration. The point to be noted here is cations having inert gas configuration can be more readily formed than cations having pseudo inert gas configuration. That's the point to be noted here. Stable electronic configuration in the sense, cations which have NS2-NP6 configuration can be more readily generated than the cations having pseudo inert gas configuration. For example, let us take two cations, namely calcium, cation from calcium and cation from zinc. Calcium 20 atomic number, right? Its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. This is the configuration of calcium. First shell, second shell, third shell and fourth shell. Last shell has how many electrons? Only 2 electrons. To get octet in the same shell, it needs to gain 6 electrons, which is quite impossible. That's why calcium readily loses these 2 electrons. Calcium readily loses these 2 electrons and becomes Ca2 plus cation, whose electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6. It has octet set of configuration of argon. Now it had acquired the argon nearest inert gas configuration. So configuration wise it is stabilized. When it comes to zinc, whose atomic number is 30 and its configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. After 4s, 3d is getting filled. Notice that. You can write 3d after this also, but as 3d belongs to third shell, I am writing all shell electronic configuration at one place. So first shell, second shell, third shell and fourth shell. Even zinc also, outer shell has only 2 electrons. Outer shell has only 2 electrons. To get octet, it has to gain 6. which is quite impossible. That's why instead of gaining 6, zinc also loses those 2 electrons and becomes Zn plus 2 cation, whose electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10. Now, zinc is stabilized with the pseudo inert gas configuration. Pseudo inert gas configuration. The question is, among Ca2 plus and Zn2 plus, which cation can be readily formed? According to this point, cation with inert gas configuration is more stable than cation with the pseudo inert gas configuration. That's why Ca2 plus can be more readily formed than Zn plus 2. Ca2 plus formation is easier than Zn plus 2. So these are the factors that influence the formation of cation. Now let's come to the factors influencing formation of anion. Now let's discuss the factors influencing the formation of anion. Anion means which has a negative charge, a negative ion, right? A negative ion. In that way we can remember a negative ion. Right. Now how to form an anion? An anion is formed when an atom gain electron or electrons. Suppose you are given with 2 atoms, larger atom and smaller atom. And we are allowing these 2 atoms to gain electrons. Question is, which can gain electron easily? Gain electron means who has to gain? Are they having hands to pick the electrons? No, nothing. So the nucleus is the one that has to attract the electrons. Who has to attract electrons? Nucleus. This nucleus, larger nucleus, cannot hold its own electrons strongly because of more distance. This nucleus is unable to attract its own electrons strongly. How can it attract an extra electron? Definitely on extra electron also still weak attraction it can show. When it comes to smaller atoms nucleus, it is firmly holding its own electrons, and because of that its influence is also high on outer electrons also. So nucleus of smaller atom can effectively attract outer electron and thus form an anion. Obviously anion is larger in size than its parent atom. We discussed that. So among a larger atom and smaller atom, which can readily form an anion? Smaller atom. So the first factor that influences the formation of anion is small atomic size. Small atomic size. Smaller the size, easier is the formation of anion. Next, second factor is less charge on ion. Less charge on ion. Suppose you are asked to generate F minus and O minus 2. F minus and O minus 2. You remember that electron gain enthalpy concept. Usually except for inert gases, nitrogen and alkaline earth metals, the rest of all elements, energy will be released when an extra electron is added. I am repeating. When an extra electron is added to an isolated gaseous neutral atom, energy is released in all atoms except for zero group elements, nitrogen and alkaline earth metals, because they are already stabilized by several factors. Zero group elements by octet, of course helium by duplet, and nitrogen is by half filled, and alkaline earth metals are by paired electrons. As they were already stable by some means, they don't want to disturb those stabilities. That's why to add an electron, energy is to be absorbed rather than the released. Understood? That's why in case of addition of electron for zero group elements, nitrogen and alkaline earth metals, it is endothermic in character. Energy will be absorbed during addition of an electron, but remaining all elements, energy will be released. First electron gain enthalpy is always exothermic for all elements except those 3, right? So when fluorine is added with an electron to generate F minus, energy released is called as the first electron gain enthalpy. Even oxygen also, when an electron is added to give O minus, gaseous, of course they should be in gaseous form. They should be gaseous ions, right, and atoms. Here also, first electron gain enthalpy is released. Energy is released. But to this O minus gaseous ion, when another electron is added to generate O power minus 2 gaseous ion, the energy change accompanied here is endothermic. It is absorbed rather than released. So net formation is O plus 2 electrons gives rise to O power minus 2. Net electron gain enthalpy is endothermic. Endothermic means it is associated with absorption of energy, which is quite less possible when compared with the exothermic, which is spontaneously happening by release of energy. Whereas for this to happen, we have to supply energy rather than emission. So among formation of F minus and formation of O power minus 2, which is quite spontaneous, which is quite easier, the one having less negative charge. So less the charge, more easier is the formation of anion. So that's why second factor is less charge on the ion. So formation of F minus is easier than O minus 2, than N minus 3, than C minus 4, etc. Right? Third factor is high electronegativity or electron affinity. Electron affinity. We discussed electron gain enthalpy and electron affinity also, right? So electronegativity is a tendency of an atom to attract the shared pair, whereas electron affinity is its ability to gain electrons. This is to attract more towards itself, this is to gain towards itself. Of course, both the factors helps us here in predicting the formation of anion. Usually more there is electronegativity or electron affinity, more easier is the ability to gain electrons. So suppose F minus, see fluorine, chlorine, bromine, iodine. So which has high electron gain enthalpy? High electron gain enthalpy shown by chlorine. So Cl minus can be readily formed than F minus, than Br minus, than I minus, according to electron affinity. According to electron affinity. Similarly, we have one more example we can take. Suppose you take the one having more electronegativity, fluorine and oxygen. Fluorine and oxygen. Which is more electronegative? Fluorine and oxygen. Fluorine is 4.0, oxygen is 3.5. The one with high electronegativity can readily gain electrons and forms an anion. So, ease of formation of F minus is greater than ease of formation of O power minus 2. Even minus also, O minus also. Even O minus also, F minus easier. F minus formation is easier than the formation of O minus. Thus, these are the factors that influence the formation of anion. What are the factors for cation? Cation factors are large atomic radius, low ionization enthalpy, less charge on cation, and fourth one is stable inert gas configuration. What are factors influencing the formation of anion? First one is small atomic radius. Second one is high electronegativity and electron affinity. And third factor is less charge on ion. Less charge on ion. Right? So these are the factors. It's an important concept for both PU board as well as competitive exams like JEE and NEET. Go through the video and immediately go through NCERT textbook explanation and come with the doubts.